And we are going to the third speaker. Okay, ladies and gentlemen, the third speaker is Professor Hiroyuki Sakakibara from Miyazaki University, Japan. Let me read a glimpse about his curriculum vitae. Professor Hiroyuki Sakakibara is professor of Faculty of Agriculture, University of Miyazaki, Japan. After getting PhD in 2002 at the Kobe University, Japan, he was worked at a postdoctoral fellow at INRA Center, Clermont-Ferrand, France, and then postdoctoral fellow at the Tokushima University, Japan. Thereafter, he obtained an academic position of assistant professor at the University of Shizuoka, Japan in 2006. Following, he moved to University of Miyazaki as an associate professor in 2012 and was promoted to professor in 2019. His research is focused on functional food science based on rodent animal models. Recently, he especially focused on preventive effect of food ingredients such as polyphenol on lifestyle-related diseases from the viewpoint of biological rhythm. Dear all participants on this conference, please welcome to Professor Hiroyuki Sakakibara to deliver a great presentation about the effect of harvest timing on antioxidant activity of soybean leaf.
Hello, my name is Hiroyuki Sakakibara and working at the University of Miyazaki, Japan. First of all, I would like to express my thanks for everyone on the organizing committee about giving me such opportunity to give the presentation on this conference. Second, I can be, it's okay. If possible, I hope to visit Malang, Indonesia, and give my presentation on site. And I had the plan. After conference, I will go sightseeing around Malang town before returning to Japan. However, as you know, COVID-19 situations did not permit my visiting at Indonesia. Therefore, I'm sorry, but I am still in Japan, and please accept today's my presentation is recorded material. And I wish and pray for everyone attending to this conference future happiness, and hope to meet you in the future, near future, and discuss anything. Anyway, I would like to start my presentation. Okay. Okay, so now I would like to start my presentation. Today's my topic is, here is the title, Effects of Harvest Timing on Antioxidant Activity of Soybean Leaf. Okay, so next slide. Here. I guess many of you know the word functional foods. Basically understand as some food or food ingredient that can regulate our body homeostasis and therefore can reduce the risk of some diseases such as diabetes, obesity, and hypertension. There are lots of researchers who investigate about functional foods, including Japan. Why are functional foods factors focused in Japan? Here. Because recently many of our Japanese, they are westernization of dietary habits, meaning high consumption of fat and milk, and low consumption of vegetables, and also increasing the opportunity to consume the fast food such as hamburger I do not know it is true or not, but increasing of patients of lifestyle-related diseases because of food habits changes. Therefore, many research groups in Japan are trying to find the foods and food factors that can prevent lifestyle-related diseases, including obesity and diabetes. Lots of functional food factors have been found for prevention from many diseases. Among them, polyphenols are major groups. Polyphenols has such basic structure here. This is a benzene ring, and they have phenolic hydroxyl group, more than 2 like this. And such polyphenols reported there are a lot of beneficial effects like this. Our group recently also reported many interesting aspects. For example, I would like to introduce some results. Here, this manuscript was published at Journal of Functional Food at 2020, last year. In this study, we focused on black soybean seed called polyphenols, such as catechins and procyanogens, and found that daily consumption of black soybean seed called polyphenols might attenuate dyslipidemia, maybe prevention from obesity. Next, examples. This manuscript was published on nutrients at this year. In this study, we focused on quercetin, one of major polyphenols mainly existed in the onion, and found beneficial effects of quercetin might move from mother to her children. Anyway, you can obtain many kinds of information about functional aspects of polyphenols. Okay, next slide. We also make the database which kinds of vegetables, fruits, and teas consuming in Japan have high amounts of polyphenols, and made a ranking using this publication little bit previously because 2003, but this paper contained a lot of data information. So we make the ranking using this paper. So this is a result. Y-axis here, this meaning the polyphenol amounts higher in this pyramid indicate containing high amounts of polyphenols. Here, for example, green tea, coffee beans, and blueberry. They are high polyphenol containers. On the other hand, carrot, kiwi fruits, and potato, they do not contain high amounts of polyphenols. Therefore, daily consumption of such vegetables, fruits, and teas might prevent our body from some diseases. This is the reason why we humans consume daily polyphenol-rich foods, although such polyphenols are not essential nutrients. Here, I have a question. How about plants? Of course, it depends on the plant sources, plant species, but most of plants can biosynthesize the polyphenols. Why the plant can biosynthesize the polyphenols? A couple of years ago, we found this question. Next slide. This slide shows the wavelengths properties of sunlight. Okay, as you know, sunlight can classify the three categories according to the wavelengths. That is, ultraviolet regions, visible light regions, and infrared regions. Okay, ultraviolet regions is further categorized according to their wavelengths. Their wavelengths from 200 nanometers to 280 nanometers. That is called UVC here. Next, from 280 nanometer to 315 nanometer. That is UVV. And from 315 nanometer to 400 nanometer, that is UVA. On the fundamental knowledge, sunlight at ultraviolet regions here has strong energy power. Therefore, when exposing sunlight at ultraviolet regions, many damages are induced and consequently induced many diseases, for example, skin cancer. However, the stratosphere layer and atmosphere layer are around the Earth, and therefore UVC and UVB regions cannot arrive at the surface of the Earth, here blocked. In conclusion, only UVA here, UVA region can arrive to the surface, and we humans should consider a counter plan for UVA, this one. Okay, so how to consider a counter plan for UVA? One of the easy way is to use a sunshade parasol here like this. If we humans use such a sunshade parasol, we can easily protect from the exposure of UVA. Yes, a human can easily consider counter plan for UVA, but how about plant? Here, how about plant? Can the plant use the sunshade parasol like this? No, I don't think so. They cannot use the parasol by themselves. Okay, so how do the plant consider a counter plan for UVA? One of the protective mechanisms is polyphenols. Polyphenols have their characteristic UV absorbance. For example, there are three typical polyphenols: quercetin, diazine, chlorogenic acid. Their structure is here. This is their UV absorbance spectrums. X-axis indicates the wavelength from 200 nanometers to 400 nanometers. Y-axis indicates intensity here. In case of quercetin, quercetin has strong absorption properties for UVA region here. Its meaning, quercetin can absorb the wavelengths of UVA. Okay, diazine and chlorogenic acid also have absorption properties for UVA, for example here and also here. If the plant skin has such polyphenols as enough amounts, in this case, plant can protect from the damage by irradiation of UVA reached at the surface of the Earth. So, from the viewpoint of plants themselves, they biosynthesize the flavonoids in order to protect from UV-induced damages. This is the tentative theory, but I think this is reasonable. Next slide. So this is the long backgrounds for my today's presentation. Here, additional backgrounds. Do you know the biological clock? The biological clock is well known to be existed in the body, including animals and plants, and therefore many biological events exert circadian rhythm. Okay, biological clock is my another research topics, but there are not enough time today. Therefore, I would like to skip the detailed points about biological clock, but I would like to show one information. Do you know this plant? Sensitive plant. When I touch the leaf, immediately they close the leaf. This is typical characteristics of sensitive plant. This plant has another characteristics that they sleep every day. Please look the movie which I made, please. Okay, so how about this movie? I think it's very interesting, and this movie clearly indicates the sensitive plant repeat wake and sleep independent from sunrise and sunset. When calculating their sleep and wake cycle, we can know they accurately wake at morning and sleep at evening, meaning 11.6 hours for opening period and 12.4 hours for closing period. We submit this data to the conference journal. Okay, so biological clock are well known to be existed in the body, including animals and plants, and therefore many biological events exert circadian rhythm. Next point, sunlight UV irradiation also indicate circadian rhythm. Okay, therefore we had the hypothesis: if biological events are affected by circadian rhythm of sunlight UV radiation, the amounts of some biosynthesized compound, it meaning polyphenols, probably different among the day. Here, so I would like to introduce two experimental data we obtained. First is indoor cultivation. We employed soybean. Here, its strain names Fukuyutaka and cultivated in the experimental house according to these environment. Here, day 0 meaning the germination day here, and we recorded their leaf movement at day 15 and obtained the evidence that soybean leaf clearly indicate the circadian movement as similar to the sensitive plant, because as shown here, opening period 11.9 hours average for 7 days and 12.1 hours for closing during the 7 days. It's almost similar. Okay, under day 18.4 here, green soybean seed and leaves were harvested at the beginning of the light period. Here, we called cytogamma time ZT0 and the end of light period cytogamma time 14. Isoflavone amounts, antioxidant activity, and gene expression analysis were carried out. Here, we employed two kinds of genes, cinnamate 4-hydroxylase and also isoflavone synthetase. These two genes are related for the isoflavone synthesis. Okay, so next is the result. So here we can see the three data. It's antioxidant activities, isoflavone amounts, and also gene expression profiles. Yellow bar indicates the harvested at the end of the light period. The end of the beginning of the light period. The beginning of the light period, and the black bar indicate the harvested at the end of the light period. Firstly, antioxidant activities. Antioxidant activity of soybean leaf indicates quite higher than that of the cytogamma time 14 here, significantly higher. On the other hand, antioxidant activities in the bean portion, we could not find any antioxidant activities. In case of isoflavone amount in green soybeans, there's no differences between cytogamma time 0 and cytogamma time 14. And finally, gene expression profiles C4H and IFS. There is significantly differences, but remarkably higher in the cytogamma time 0 period comparing with the cytogamma time 14. These result indicating that flavonoids synthesized, isoflavone synthesized are accelerated in the beginning of the light period. Okay, so we move to the next experiment. Here we used same soybean strain named Fukuyutaka and cultivated at outdoor according to this environment. At day 99, green seed, its Japanese name edamame, was harvested, and then dry soybean seed, Japanese name daizu, were harvested at day 120. Okay, following isoflavone amount, water content in soil, and gene expression analysis were carried out. So this is the result about the water content in soil and the gene expression profiles of lax C. Firstly, I show the data about water content in soil because some researchers reported that water content in the soil affects the diurnal patterns, but diurnal differences were not observed in the water content in soil, as you can see here. Next, the gene expression profile is known LAX. This gene is well known to exert circadian rhythms, so-called clock genes. This expression indicates typical diurnal rhythms on the green soybean, like this, and reached at maximum at the middle of the day. On the other hand, could not find the rhythmicity on the dried soybeans. Here, following this data indicate the gene expression profiles of CH4 isoflavone synthetase and also isoflavone reductase. Among these three isoflavone related genes, only C4H indicate the clear circadian rhythms, especially on the green soybeans like this. On the other hand, dried soybean red circles did not indicate the clear circadian rhythm, diurnal rhythms. Other two genes, IFS and IFR, did not indicate the diurnal differences. Only CH4 indicates the diurnal rhythms. About isoflavone amounts here, on dry soybean harvested at 6, here red circles here indicate higher amount than that of the other timing, and also lower at ZT4 here on green soybeans comparing with the other harvesting timing. So this is the conclusion of this presentation. Firstly, we hypothesized if biological events are affected by circadian rhythm of sunlight, its meaning UV irradiation, the amounts of some biosynthesized compounds probably different among the day. And we obtained the following interesting data. First, soybean leaf has clear nicotinetry indicating circadian rhythm. It's similar to the sensitive plant. Antioxidant activity of soybean leaf might be higher at the beginning of light period than that of the end of light period. In green soybean, it's meaning edamame, in case one of typical clock genes, laxes, exert clear circadian rhythm. Gene expression of cinnamate 4-hydroxylase C4H reached at middle of the day. Finally, isoflavone amounts are lower at middle of the day. In dried soybean, daizu, Remarkable differences were not observed on the gene expression, including cloxine, laxase, and isoflavone synthetase. Isoflavone amounts are higher at the middle of the day. So this is a conclusion. Therefore, our data clearly indicate the harvesting timing might be important for the functional effects of plantal foods. In our opinion, the vegetable harvested at morning probably good for our health than that of harvested at night, but it's a quotation. Therefore, we have to continue this study, and if possible in the future, I would like to give the another result and the another opportunities. Okay, so it's a time for closing. Thank you for very much for your kindly attention. And this is acknowledgement for this presentation. Okay, thank you very much.
Okay, thank you very much for Professor Hiroyuki for stunning presentation. I do agree that your ideas about food can prevent lifestyle-related disease, including obesity and diabetes, is quite adorable for us to think further. Now the question and answer is opened. Anyone who has question, please click raise hand button or type your question in chat column. Okay, let me check. Is any question in the chat column? Okay, Professor Hiroyuki. The question from Fatimah Nursandi.
Okay.
So the question is, what is the economic potential to produce polyphenol using apple culture techniques? Because her research by adding phenylalanine 250 milligram per liter can produce flavonoid 275 milligram quercetin equivalent per gram dry weight apple callus. Okay, Professor Ryuki, you can give direct response.
Yeah, so what is the question? So please again.
Okay.
I could not catch everything what you
Okay.
say.
Okay, you need repeat the question. Okay, so the question is, what is the economic potential to produce polyphenol using apple callus culture technique? Because her research by adding phenylalanine, 250 milligram per liter can produce flavonoid 275 milligram quercetin equivalent per gram dry weight of apple callus.
Yeah, so thank you very much for your question, and it's very difficult for answer economic potential, but I guess it depends on the polyphenol species. Now today we gave the quercetin and isoflavones, so maybe quercetin has a very strong activities. So in the future, I would like to give the answer. Now I don't have any answers. Sorry.
It's no matter, Professor Hiroyuki. So any question for the others? Please raise hand, or maybe you can type your question via column chat column, sorry. Okay, nobody. So let me deliver my question. Okay, Professor Hiroyuki. I'm curious how to best way to consume the polyphenol resources. It's mean whether in raw material or maybe we need less processing. Thank you.
Your question is about the processing. Processing means how
to best way to consume the polyphenol resources.
So it's maybe it's a fresh condition.
Yeah, the fresh condition, or
yes,
maybe less processing.
Yeah, yeah, it's better.
Yes. Okay, the fresh condition.
Yes.
Okay. How about maybe the food or maybe the resources that needs processing, like maybe the leaf of soybean? Is it possible to consume in raw?
In case of the soybean, it's very difficult. So, example, it's a tofu and miso shoyu. We have to make the preparation, but we have to. We can trace the amount of the polyphenol during the processing. So maybe we can easily say something. Yes.
Okay, thank you. The last question, let me check anyone has raised hand. Okay, to Miss Desiana Nurisha Putri. Okay, you can deliver your question directly.
Okay.
Thank you, Miss Rista. Good morning, Professor Hiroyuki. Let me ask one question. So based on your presentation, the data show that isoflavone amount in green soybean was quite higher than in dry soybean when they were harvested in the middle of the day. My question is there any correlation between the amount of water in soybean with synthesis of isoflavone? Thank you.
Yes, thank you very much for your question. I agree with the question. Maybe it's a correlation, but so green soybean it's a fresh and dry soybean it's a dry. But now I give the data fresh weight. So maybe during the dry process, polyphenols, including the isoflavone, maybe their amount will be changed.
Enough for Miss Desiana about the professor response.
Okay, thank you for the
Okay, thank you very much. So, ladies and gentlemen, the question and answer session is closed. I would like to sorry due to the limited time. The summary from the third speaker is what you are is what you eat. The steak, your best food to keep your health. Well, let me deliver the certificate to give the deepest appreciation to Professor Hiroyuki.
Thank you very much.
Okay, and please to all participants and third speaker to take a picture. Share your wonderful smile. Okay, I count down 3, 2, 1. Okay, thank you very much, Professor Hiroyuki. See you for the next occasion.
Yep, thank you very much.
Keep healthy. Okay.